All right. Hello, everybody. Welcome to one of our final fireside chats, actually. I think this is our 12th one from Hugging Face, who are also an official partner of the Vercel AI Accelerator. You all should have gotten an email if you signed up for Hugging Face credits to join the Vercel AI Accelerator Hugging Face org and get access to credits. So shout out to Hugging Face for all those credits. Yeah, today we have Joshua from Hugging Face that's going to come and talk to us about specifically about an app that he built using the Hugging Face Inference API and the Vercel AI SDK. And it's an app that helps folks chat with YouTube videos. So without further ado, please take it away, Joshua. Thanks for being here.
Thanks so much. Yeah, definitely. I'm going to be talking about sort of like fitting it into fitting the application into like the broader ecosystem that sort of Hugging Face provides for JavaScript developers. And as I'm not too sure if anyone else knows or can hear from my accent, but I'm from South Africa, and funnily enough, it's 2 a.m. here. But thankfully, the excitement of discussing how you can use Hugging Face tools in your JavaScript applications is keeping me wide awake. So yes, anyway, I'm Joshua, the creator of Transformers.js, which is a JavaScript library for running transformers locally. I also recently joined Hugging Face sort of as an open source machine learning engineer. And my main focus at the moment is sort of, growing the community, which is sort of done by like trying to bridge the gap between web development and machine learning, which is typically it hasn't really been an overlap until recently with these amazing tools such as the Vercel AI SDK that I'll be chatting about soon. So I guess just a small introduction about Hugging Face. If you've been in the AI space long enough, you're probably already familiar with Hugging Face, but just for those who are getting started, the slide's for you. So in short, Hugging Face is the go-to platform for the machine learning community, enabling collaboration through sharing of models, datasets, and applications. And as of August 2023, there are over 510,000 models, 260,000 applications, and 240,000 datasets shared on the hub. And these numbers are growing by thousands every day. We're on a journey to advance and democratize AI through open source and open science. And this is primarily led through the numerous open source libraries that we maintain, like transformers, diffusers, and tokenizers, just to name a few. Now, up until a few months ago, the only way to use these powerful models was from Python. After all, it is the predominant programming language for machine learning. But fortunately, there have been a ton of recent advancements in the field of web AI, both in-browser and server-side. And to quote the infamous Atwood's law, any application that can be written in JavaScript will eventually be written in JavaScript, and this is no exception. Considering that JavaScript is one of the most used programming languages among developers, it felt like a natural progression to bring the Hugging Face ecosystem to web developers, mainly through our Hugging Face.js and Transformers.js libraries. And let's just start quickly by taking a look at them in a little bit more detail. So first up, Hugging Face.js. Hugging Face.js is actually split into 3 submodules. So first of all, the inference library acts as a wrapper for the Hugging Face Inference API, allowing you to make calls to almost any model on the hub. And specifically for the demo, which I'll showcase later, I use the Hugging Face Inference API combined with the Vercel AI SDK to sort of provide an a conversational streaming application. And so anyway, second of all, the hub library provides a way to interact with the Hugging Face hub, including managing and accessing different repos across the hub. And lastly, the agents library allows you to interact with Hugging Face models through a natural language interface, where an LLM is given the ability to make calls to the inference API. So using the Hugging Face Inference API, you can make requests to almost any model on the hub directly in your JavaScript applications and just using a few lines of code. From basic NLP tasks such as text classification and translation to more advanced and multimodal tasks, such as text to image or automatic speech recognition, we've got you covered. You can check out the documentation for the full list, along with any example code you may need to get started. And yeah, so another feature of the Inference API, which has become exceptionally popular recently, thanks to the rise of conversational LLMs, is stream text generation. And moreover, its integration into Vercel's AI SDK makes it super simple to build conversational streaming user interfaces in JavaScript and TypeScript. And next up, the Hub library offers various utilities to access the Hugging Face Hub directly in your JavaScript or TypeScript applications. This includes creating models, datasets, and spaces, as well as uploading and downloading files to and from these repositories. And lastly, the newest addition to the Hugging Face.js ecosystem, released only around 2 weeks ago, is the Agents.js library. The library provides a way to call Hugging Face models and Inference API within an LLM. Considering the wide variety of APIs available in a browser, we think that there's some serious potential to create some really powerful web applications. Imagine a browser extension which can act semi or fully autonomously. So I can only imagine what people will create with that. If you want any more information about that, you can check out the Agents.js blog post. And if you prefer to run inference locally, we also offer the Transformers.js library, which will allow you to run Hugging Face transformers directly in your browser or server-side in Node or Deno. Transformers.js is designed to be functionally equivalent to the Python library, meaning you can run the same pre-trained models using a very similar API. We provide high-level abstractions for running state-of-the-art pre-trained models directly in JavaScript, meaning anyone can easily add machine learning functionality to their web applications. We also have an amazing growing community on GitHub, full of people who really see the potential of WebML. And with full web GPU support right around the corner, we anticipate a massive explosion of interest and innovation in the coming months. Yeah, just to quickly discuss some of the applications or tasks it can perform. We currently support over 25 of the most popular model architectures, and these cover a wide range of input modalities, but definitely more are coming. It's definitely not the same. It doesn't have all the features as the Python library just yet. I guess a quick brief mention of sort of how it works. You first convert your models to Onyx with one of our libraries called Optimum. Next, you write your JavaScript code, and you can really get started in just a few lines, trying to sort of emulate the simplicity of the Python library. And finally, just run it. It's really that simple. I mean, there's obviously a few limitations. You can't run some of the larger models, but we got to start somewhere. I guess
I had a question for you, Joshua, if you don't mind.
Yeah, sure. Yeah, please do.
So you're talking about Transformers.js, which is this library that you made where you can run a lot of these machine learning models in the browser. Can you talk to us about what the difference is between using that and between using the Inference API like you showed us before, where you can do await like Hugging Face text classification, something?
Yeah,
like, how is that different from Transformers.js?
Yeah. So I guess the easiest way to sort of just differentiate it is where is the inference happening? Where are you actually running the models? So with Transformers.js, I guess originally it was designed to be only within the browser. Like when I created it first, I didn't really think of it as being applicable to server-side environments. I didn't think of it that way, so I just ignored that. I just ignored that use case in the beginning, and originally it was actually also for a browser extension, which is a little bit funny now that I'll soon be presenting about building browser extensions with these AI tools. But I wanted to run I wanted to run Hugging Face transformers in a browser extension, but nothing really existed. So I was like, okay, fine, I'll do it myself, as all sort of all projects seem to go nowadays. But yes, so the idea is that you do not have a server at all. This was the original pitch, I guess, but it has actually expanded quite significantly, which I'll talk about now. And Transformers.js will allow you to not have to make a call to a server other than downloading the model, first of all, obviously. And this will sort of allow you to run locally in, I guess, any browser-like environment. You can think of like Electron applications, or I mean, simply in the browser, but also now as it's expanded to server-side applications where you're actually running inference locally. It's a bit of a contradiction in a sense, but what I mean is you're running it on your server instead of handling that off to another API, which is what the inference API and how it differentiates itself to Transformers.js. So the inference API is, I guess, it's sort of connected to a larger thing at Hugging Face, which is inference endpoints. And I guess it's also called the inference API, but the inference API for JavaScript is simply a wrapper around that. And what that allows you to do is to make a call to some hosted models that we've got. I mean, you can make a call to any model, but there may be some cold starts here and there. But for some of the larger models, you can simply make a call to the pipeline function, essentially like text classification or text to image or whatever you want. And it will then call the model and run it on Hugging Face's servers, basically. So yeah, hopefully that sort of explains the difference. It basically just comes down to where the model's actually running.
Right. So to rephrase really quickly, for the inference API, that's going to trigger some hosted model on Hugging Face. So you have to, it costs money, right? You have to pay Hugging Face to run for every invocation or whatever it is.
Partially. So yes, that's basically correct. So you can get started with the inference API for free. There's no, you can actually, like some of those examples, you can, actually, I think all the examples I showcase now, you can just get started without even having to provide an API key, but that you will get rate limited, of course, eventually. Right. Hopefully you won't abuse that. But the idea is that once you start using it in big applications, then you'll need one of your Hugging Face access tokens, which is free. You can get that for free. And then later on, if you really need a production grade, if you need this to be run in production grade applications, we do recommend that you get either upgrade to Pro, or you can host your own model on the inference as a hosted inference. What's the correct terminology? I think it's inference endpoints. It's all these funny words, but yeah, that's sort of the differences. But yeah.
So that's the flow. And then where does Transformers.js come into play? Because you said you could run models directly in your browser. So would you even have to pay for workloads to run elsewhere if you could?
That's the beauty. You can right. It's all these different.
So it's like free forever, kind of.
Exactly. That's sort of the goal of Transformers, the Python library as well. And that's sort of what we're trying to emulate with Transformers.js is local on-device machine learning, which is you own everything, you run it, and it's using your compute, it's using your device to run the compute. So other than simply downloading the model from the hub, I guess that's sort of the only cost that Hugging Face incurs, but you don't have to worry about that.
Very cool. Is there a reason why everybody doesn't do that? Is it, only restricted to specific models that are lightweight enough to run in the browser?
Yes, right. So that's definitely what the main limitation at this point. So I guess I can quickly scroll through some of the slides on screen now, sort of the various tasks that are able to be run, and then the ones that sort of can't. So you can't yet, actually, there's a bit of an asterisk next to that. You can't yet run, let's say, Llama 70B in your browser. Like, obviously, I don't think browsers are the best environment for that. But you can. There's actually been work done to run the 7B version of Llama V1 as well as Llama V2, running that in your browser with WebGPU, and that's really exciting for the future. I think. But for the moment, I guess dialing back expectations a bit, just to showcase like sort of these not overhyped. these tasks in machine learning have been available for many years. It's not like a new thing. But the new thing is getting them running in the browser, and these very small, like 100 megabyte models. And I say it's not exceptionally small. Some of the models we've got to like around 20 megabytes. But for like pretty decent performance in some of these things. So like this text classification model, I think it's around 100 megabytes, and token classification and code completion. And these things that are especially text-based tasks, they're relatively cheap computationally. I guess just by their nature, the input is text. It's just a bunch of numbers after you convert them into tokens. But as you move on to more advanced things like vision, I guess this is where the computation gets a little bit more hairy. But there's been a really great work. So as you see the last image at the bottom with Meta, some of the segment anything demo that they released was actually running in browser, which is a really exciting use case. And the, I guess, image classification as well that I'm showcasing, the model actually is only around 40 megabytes, and it produces really high quality results. Like as you can see in the image there, it's these bounding boxes that are generated. It's quite surprising how what you can sort of get with really small models. And one of the, I think, probably my most favorite use case is running Whisper in the browser. So this is a little application I developed around a month ago. Probably, yeah, actually, I think it's almost exactly a month ago now. But it basically just allows you to run Whisper direct in the browser, no costs, which is insane. I mean, I was really happy to get this working, and I mean, it's built. I'm building on the shoulders of giants because some of the tech I use, it's called Onyx Runtime Web specifically, and that sort of like the PyTorch of in-browser inference, I guess, which is a bit interesting. But yeah, and then lastly, I'll just quickly cover the multimodal tasks like embeddings and image to text. Those sort of like more general, and definitely as Web GPU is currently being brought out and being supported, I think these types of tasks will be very, very interesting to see. But anyway, now finally we can get to the applications that we've all been waiting for. And I guess that I'll sort of be covering two of them that I recently built. So first of all, as it was mentioned, the chat with YouTube browser extension, and secondly, the semantic image search engine. The first one is built with the AI SDK, Next.js, and Hugging Face inference endpoints. And the semantic image search engine is made with Transformers.js, Next.js, and Supabase. But I'll cover them in more detail now. So the chat with YouTube browser extension is built with, as I mentioned, Vercel's AI SDK, and it makes it extremely easy to build user interfaces for conversational LLMs. And once I get into the code, you'll see that actually the machine learning side of things is remarkably short. In fact, the machine learning and the UI was the easiest part of the project. Most of the time was actually spent setting up the extension and debugging Webpack issues, which is not fun for anyone who's ever done it. It's just reading documentation, and it's really not fun. I would advise against it. Unfortunately, on that note, the source code of this for this will all be open source. So please look at that and don't waste your time with Webpack. It's not worth it. Yeah, anyway. So, but the way it works is really simple. All I do is I basically just put the transcript as additional context to the LLM when prompting it. And in this case, it's the 7 billion parameter version of Llama 2. And since we're running in the context of the web page, we actually have access to the video's transcript directly. And since Llama 2 has a relatively large context length of around 4,000 tokens, we can actually insert the entire transcript directly into the model's context window. So of course, for longer videos, we need to implement some chunking and retrieval augmented generation. But for now, we'll leave that for future work. And as you can see in this demo video, I ask it to summarize a 14-minute long video about the new app router in Next.js. And this conversational assistant can really be useful in situations like this, where the LLM can analyze the information-heavy content and assist the user with like summarization, analysis, and providing explanations when needed. And in case you wanted a summary of the video as a limerick, you can do that too, as I'm showcasing now. Llama 2 is quite the poet. Yeah, it's quite fun being able to play around with these things. And anyway, going sort of into a little more detail, the application is split into two parts. So first of all, the server, which is just a simple Next.js application with the only purpose of hosting the API/chat endpoint. And this is something that's required by the AI SDK. And secondly, the client, which is a React component that we embed into the web page, that we inject into the web page. So the way I got started sort of building this was simply using the create next app, and alongside with the next Hugging Face template that's provided. And then all we have to do is update the environment variables with the Hugging Face API key and endpoint URL. And if you haven't got these, you can follow the link on screen and it'll walk you through how to get set up. But now, finally, let's get into the code. And funnily enough, most of it actually all stays the same. As it says the same as the template. So first of all, we switch to our custom inference endpoint and add our API key. Second, we convert, we set the model to Llama 2 7B. You can just specify the model ID there. And we also use the build Llama 2 prompt helper function, which is provided by the AI SDK. This will just convert our messages into the format expected by the model. And since Llama 2 has a 4K context size, we can update the generation parameters accordingly. And lastly, all we have to do is update the response headers just so that we can call the API from our browser extension. And believe it or not, that's actually all we need to do to get for the server side of things. Let's move on to the client. So most of the section involves very application-specific code, which in our case is about injecting a React component into onto the right side of a YouTube video, which is not really relevant, I guess, to this talk. So to keep it brief, I'll just focus on the AI part of it. And as always, just feel free to refer to the source code for all the details. I guess once again, when we can sort of start with the code provided by the next Hugging Face template, specifically the page.tsx file. And I guess then after we do that, we can just use we can update the parameters of the use chat hook, which is, so first of all, to point to the API that we just created. And secondly, to add the system prompt, which is, and it's extremely simple to do. And it's a very simple prompt. All we do is insert the metadata and transcript of the video, and then ask the model to answer any questions that follow. So one thing to note is that if your system prompt contains sensitive information, you can easily move this to the server. But for now, this isn't really that sensitive. I mean, it's a very simple prompt. You're a helpful assistant. Answer questions that follow. It's nothing too specific. So for now, we can just include it here. And as for the user interface, we actually basically keep it the same as the template, just adding some styling and filtering so that we don't show the system prompt in the chat window. And yep, that's it. You've now created a chat with YouTube browser extension, thanks to Next.js, the AI SDK, and Hugging Face inference endpoints. So sort of what now? Well, there are some improvements that I can think of off the top of my head. So at the moment, as I mentioned before, we send the entire transcript to the API for each message. Ideally, we would use a vector database or something to combined with, I guess, retrieval augmented generation to only select relevant chunks of the transcript when prompting the LLM. This will also cut down on any costs you may incur because the number of tokens you're sending is way less. And then another thing we can do is maybe add some more metadata, such as the YouTube, the video description. That's one thing, maybe even comments if you want to analyze those. And then another fun one, which is a bit beyond the scope of this example, was is to combine the visual information from the video with the transcript. Maybe a button to caption the current frame or something similar. I guess that'll be that's an interesting way to take this. And then lastly, if you're feeling really adventurous, why not just let the LLM roam the internet for you? What's the worst that could happen? Maybe combining this with agents.js or something similar. But if you have any ideas, you can just fork the project or just use it as inspiration for any of your future endeavors. So moving on. So for the second demo application, I just built a really simple semantic image search engine with Next.js, Transformers.js, and Supabase. And just before I jump into the code, I'll just explain a few concepts. So semantic search is just a technique used in information retrieval and natural language processing to improve the accuracy and relevance of search results by understanding the meaning behind user queries and the content of documents. And this is in contrast to traditional keyword-based search, where results are determined based on the occurrence of like specific keywords or tags that you've added. Instead, semantic search focuses on understanding the context as well as the intent of the query. Now, in our case, the documents are a set of 25,000 unlabeled images. So you might be asking, how on earth will we be able to search through these images without labeling them first? Well, surprise, surprise, the answer is machine learning. We will be using a powerful multimodal model called CLIP to generate embeddings for each image in our dataset. So CLIP is trained to learn a shared embedding space with similar images and text pairs being mapped to vectors that are nearby each other, basically. And this can be used for semantic search. So after populating our database with these image embeddings, we can then compute a text embedding for user query at runtime, then search the database and return the top results according to some similarity metric, which in our case is just cosine similarity. And finally, let's get to the code. So as mentioned before, it's built in Next.js and Transformers.js with inference running server-side instead of making calls to an external API, which is sort of part of the explanation that we were talking about earlier, where the sort of difference between where you are running inference, either, I guess, quote unquote locally, but you're locally as your server instead of running it in some remote server, not that you don't own, for example. And just in the interest of time, I'll just cover the important parts of the code, which is the machine learning, of course. And now, just like the Python library, Transformers.js offers two useful model classes. So the first one is clip text model with projection, and the second is clip vision model with projection. And these can be used to compute text and image embeddings respectively. And now for our backend, we'll once again be using Next.js, this time with combining it with Supabase as our database. Supabase also supports the PG vector extension, meaning that we can create a search function that will do the similarity comparisons for us. And trust me, this is way faster than getting any amount of the results and performing these similarity calculations in JavaScript. It's not worth it. The time taken. I did some tests on that, and PG vector it's quite fast. I know it's been getting a bit of heat lately, some performance measures here and there, but for this purpose, it's really, really good. But anyway, like the last application, we can just create a simple route handler to take the user's request query and search the database for the most similar images. And now, as for front end, it's just adapted from the image gallery starter template, which among other things provides various optimizations for loading images like lazy loading and blur placeholders, which really adds to the user experience. And now, putting that all together, we get a simple but powerful image search engine, thanks to Transformers.js, Next.js, and Supabase. And of course, I had to just end on, the most adorable dogs you can. I mean, who doesn't want to see that? And yeah, so just to summarize, we looked at how you can build AI applications in JavaScript with Hugging Face. In particular, we offer two powerful JavaScript libraries, Hugging Face.js and Transformers.js, which can be used to supercharge your Next.js applications. And I look forward to seeing what you build. Thanks for listening. I hope to answer any questions you may have.
Thank you so much, Joshua. That was amazing. Very, very well put together presentation.
Thanks.
I had no idea about Transformers.js, by the way. This is like today I learned moment for me. So I appreciate you going over that. But yeah, let's transition into Q&A. We have 12 minutes. So anybody have any questions? And if not, I can hop in with some of my own. Well, I'll give folks the chance to type up questions if they want to in the chat.
But I see some in the chat. So someone said, is that Whisper v2? So the first, I guess, if I can go back to it. So this demo just used, I guess, so Whisper v2, I assume you're referring to the large, Whisper v2 large, or large v2 or whatever it's called, which is like a really large model. And unfortunately at the moment, those types of models, so I'm just trying to find the slide where I talk about it. Here it is. So those models are just a little bit too large to run. So the largest one I was able to run in the browser is Whisper Base, which is, and once quantized, I think it's around like 400, 500 megabytes, which is actually really large. The one you're seeing now, the tiny version, is only around 60 megabytes, which is really, I guess, possible to be run in. It's applicable to these types of use cases. Like, and once it's cached, you never have to download it again. So it's only a one-time thing. But yeah, hopefully that answers your question, Eric.
Yeah, go ahead, Eric.
Hey, got an echo. Hold on. Sorry about that. Have you tried running any of this in Cloudflare? I mean, you know, you're in the browser, so presumably web APIs, but you know, you've got sort of a V8-ish environment over there, or in Dino, or sort of the server-side JavaScript environments.
Yeah, absolutely. So actually, we're actually working with Cloudflare. Are you familiar with their new AI? Was it ai.cloudflare or something.com? I think it's, I can't remember the exact domain, but they recently released this thing called Constellation, which is basically AI on the edge, which is a very similar thing to what we're doing. And actually, if you look at the code behind the scenes, they're using Transformers.js, which is really, I'm quite honored about that. It's really exciting to sort of see like a massive company like Cloudflare sort of interested in these types of projects. And yeah, so running on the edge is very possible. Cloudflare workers, or yeah, that's the one, Constellation, or as I mentioned before, with Superbase that was announced on Monday. And actually the ai.cloudflare, that was released, it was either this week or last week, late last week. Time's flying by, so I'm not even 100% sure. But it was quite similar. And yeah, we're in conversation, or we're in discussions with the people at Cloudflare. And yeah, really, really exciting things are coming. I won't spoil too much.
Is there anything about, I mean, you were talking about caching, so I don't really have a sense of your, I guess, memory limits on the server side versus on the client side. I mean, all I know is that Chrome can eat up all of my RAM.
Yes,
so
from my perspective,
limit is much higher locally. I'm not sure.
Yeah, actually, it's a very, very good point you're bringing up. And funnily enough, from my perspective, it's from like the JavaScript library developer's perspective, I'm so grateful that Chrome can eat up anyone's resources, because it just allows you to build these amazing applications, which is it's not ideal, because no one really wants to download large models. So just as I guess as an experiment, I developed a translation application. I think it's one of these ones over here, the bottom right one. And it's a 600 million parameter model. And I think what we were storing was about 1.2 gigabytes, literally in the browser cache, which is kind of mind-boggling that that's sort of allowed. But yeah, it was able to download and cache 1.2 gigabytes using it's called the Web Cache API. And it's just an API for caching request and response pairs. Just because we host all the models on Hugging Face on the Hugging Face hub, it just makes it easier to sort of cache the model weights, I guess. But yeah, and one of the major things that we really want to get improved is better model caching and I guess sharing across domains. So currently with the browser APIs, it's very limited to, or one of the limitations is that you're not allowed to share resources like cross-origin. You can't, if you download the model once on my website and you've got your own website, the model weights are not shared, which is quite a big limitation at the moment. So there are ways to get around it, like the file system API. You can literally grant access to like a folder on your desktop or something, and that's where all the model weights will live. And you can do that with all your applications, all your websites that you want to grant access to some model. But later on, and I really hope this gets done, you can imagine like a Chrome web store, but for model weights, which I think is really an exciting prospect. So it's something that's quite interesting. Yeah, that's sort of like a big hope that I have that sort of gets done, I guess. Yeah, hopefully that sort of answers your question. Yeah.
Cool, thank you.
Great. I had a quick question, actually. So historically, honestly, I haven't really used Hugging Face because I always saw it as like, this is for machine learning engineers. You know what I mean? This is for like the hardcore Python people. And more lately, I've been seeing a lot of JS stuff come out, what you said about Transformers.js and everything like that. So I'd love to hear more about like, how far does the JS stuff lag behind the Python stuff in Hugging Face, and how focused are you guys on the JavaScript side of things?
Yeah, definitely. And I guess that it's a funny thing because before working on this little project, I wasn't even a JavaScript developer. I guess that's how all these things end up going. We'll turn to the dark side. But and as an example, like I had no idea what I never built anything with the React. I've never done like a Next.js application. It's kind of like weird that I sort of landed in this environment because, as you're saying, I guess I would classify myself still as like a predominantly a Python developer, and I've been working with like Hugging Face tools for like years now. And I agree that like you wouldn't think that these tools are available for JavaScript developers. And I guess before I even created this Transformers.js library, I guess that was my sort of my perspective of it as well. Like I didn't see that sort of it being used in the JavaScript ecosystem, just because I wanted to build a little project that needed it. So I was like, okay, fine, I'll build it. But now that I've seen, like, I've been able to work with some of the people at like the Hugging Face JS team specifically, they're also now really interested in being able to bring this across to the JavaScript ecosystem. And I think that's it's only growing, and with things like Web GPU support coming out soon. Oh, it currently is out, but the backends are not yet supporting all the operations. And definitely Hugging Face is very much it's a massive thing for I guess Hugging Face to sort of expand into this new ecosystem of web development, and being able to sort of provide the tools and the ecosystem. And I guess that was what I found when I first created this thing, this Transformers.js, is that there is so many tools available that are, it's not specific to Python or JavaScript. Like, I mean, hosting models on the hub, I mean, that's a major plus. And with, for example, Optimum being able to convert to Onyx, and tokenization, and just a bunch of tools, and being able to now just create that bridge to the web development community, I think is a massive benefit for everyone involved. But yeah, I'm glad to be a part of it. Yeah.
Awesome. That's great. I appreciate the answer. And with that, I think we can close out and let you get to bed, Joshua. I know it's like 3
it's
a.m.
almost
for
3
you
a.m.
over
now,
there. So
it's all
yeah,
good. It's all good.
thank you so much for coming out, man. We appreciate you. And yeah, thanks for all the info.
Yeah, no worries. Thanks for the invite. It was actually fun putting this little slideshow together and building those little applications. I guess like it's a balance of, as a library developer, you want to balance sort of making adding features to the library and balancing that with like developing and showcasing examples. So it's a difficult balance, but being able to develop some of these example applications and then share some of the code and show people what's possible, I guess. It helps accelerate the dream.
I love that.
Anyway.
I love that. Cool. All right. Well, thanks again. Thanks everybody for showing up as well, and have a great weekend, everyone.
Yeah. Cheers, everyone.